Hi everybody and welcome to another Bowtie Teacher video. Today we're going to be looking at the Edexcel GCSE Maths Paper 1H from June 2019. Let's get started. So this paper is a non-calculated paper, and as we look at question 1 we have a probability that we know is going to be adding up to 1. So these two boxes, whatever they have in them, is going to be worth 0.8, and it says the number of red cubes is equal to the number of yellow, so we're going to share that probability equally between the two like that. Question part B, it says there are 12 blue cubes in the box. So the probability of getting blue is 0.2, and that's also representative of 12 blue cubes. So that 0.2 probability is 12 cubes. So if we divide both sides by 0.2, that will give us our number that we have, because usually we would multiply by the probability and tell us the number of cubes. So we're going to divide by the probability and get back to where we were. So dividing by 0.2 is the same as timesing by 5. So we're going to have 60 cubes that are blue. For question 2, we have some ratios here. 50 grams of sugar is going to make 15 biscuits, but we need 60 biscuits. So we're looking at how many 15s go into 60. So that will be 4 lots. So that means the amount of flour that we need is going to be 3 times as much as the sugar. Okay, so 4 lots of 50 is going to give me 200 grams of sugar. That is for 60 biscuits. And the amount of flour that you need is 3 times that. So it's going to be 600 grams. To buy all the butter to make 60 biscuits. Okay, so we still need 4 lots of everything. So we have 200 grams of sugar is going to be for 60 biscuits, and the amount of butter is twice that. So we're going to have 400 grams of butter, and they come in 250 packs. So we divide this by 250 and we get 1 point something. So we're going to need 2 packs to give us 500 grams. So we're going to need to actually buy 2 packs of butter there. Highest common factor, so we're going to do 72 is going to be broken down into 2 and 36, 2 and 18, 2 and 9, 3 and 3, and 90 we can do 90 can go 9 and 10, 3 and 3, and 2 and 5. So the highest common factor will be, we have a 2 in both, we have a 3 here, and we have another 3 here. And when we multiply 2 times 3 times 3, we get 18. A plan front and side elevation. So from the top, the plan is a circle, and the diameter here is 4 centimeters on the grid. And the height of these is 1, 2, 3, 4, 5. So 5 centimeters in height there. And when you look at it from the front and you just see this sort of rectangle shape, and from the top it's a circle, that means we're actually going to have a cylinder here. So the dimensions of this are going to be 4 centimeters going across, and it's going to be 5 centimeters in height. Question 5, we're doing a reflection in the x-axis. So to get from each point to the x-axis, we can count how many squares and do the exact same on the other side. So from this corner we're going down 2, so we'll go another 2, and from this corner at the top we're going 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5 down there. So that's the reflected shape here. And then if we take one of the corners, let's say this top left corner here, we have to go 1, 2, 3, 4, 5, 6 to the left, and we have to go 1 down. Okay, so our column vector will be -6, -1 to go from this reflected shape to B. We're selling different packs of pens here, and we have the packs sold in a ratio of 7 to 3 to 4. So the number of pens within this first one, which is the black pens, we sold 7 lots of 2, so we've got 14 there. For the red pens, each pack has 5 and we sold 3 lots, so that's 15. And then for the green, we have 4 lots of 6, that's 24. Okay, so when we add all of those up, we get 14 plus 15 plus 24 is 53. And we've got a total of 212 pens were sold. So we're going to do 212 divided by 53, and that's going to be equal to 4. So we can scale up the number of pens that we have. So this is kind of like when we did ratios, and this is the scale factor that we're using. The number of green pens that we had is 4 lots of 4, and then times by 6 there. Okay, so we're going to do 4 times 4 times 6 is 16 times 6, which is 96. We have 2 rectangles here. QR is 10 centimeters and BC equals PQ. We don't know what they are, let's just call them X. The perimeter of that is 26, the area is 45. So we can work out that 10 times X is equal to 45 for the area, so X is 4.5 centimeters. And now we know that this is 4.5, and the opposite side will be 4.5, but the total should be 26. So we've got 4.5 times 2 there, which is 9, and we can subtract that from 26 to give us 17. So each side here is 17 over 2, like that. So the length of AB is 17 over 2 centimeters, or 8.5. Question 8a, we're going to do an estimate for this. We've got roughly the square root of 64 for this one first, and then 101.7 is roughly 100. We can split these apart just like normal surds, and we have 8 times 10. So this is approximately 80. 2.3 to the power of 6 is 148. So what would 0.23 to the power of 6? Well, 2.3 divided by 10 will give us our 0.23. And I'm going to raise that to the power of 6, because I know that 2.3 to the power of 6 on the numerator is going to be 148. And on the denominator we have 10 to the 6, which is 1 million. So we're actually going to do 148 divided by a million. So let's move the decimal point 3, 4, 5, 6. 3 zeros under there, and we get 0.000148. 5 to the power of negative 2 is the same as 1 over 5 to the positive 2, so the minus sign does a 1 over, so that gives you 1 over 25. Two fractions multiplied together is 3.5. We change it to top heavy, so 2 times 3 plus 1 gives us 7 over 2. Multiplied by 5 times 1 plus 3 is 8 over 5. Cross cancel these, because they've got a 2 that goes into both of those, and we have 28 over 5. And as a mixed number, we're going to have to divide 5s into 28, which go 5, remainder 3. So it's 5 3/5. Simultaneous equations, where they cross over, that is the coordinates of the crossover, also gives us the solutions to the equations. So when we read off this x coordinate here, we get 2.2, so somewhere between 2.2 and 2.3 they'll allow 2.25, and on the y we've got negative 1.123, just over 1.3, so 1.32. Okay, there'll be a range of values that they'll allow for that one. 23 people, and we have to find the median, so we add 1 to 23 and divide by 2, that gives us 24 over 2 is 12, so the median is the 12th one. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 is 59 there. And then we split the rest of the data in half. So 1, 2, 3, 4, 5, 6 there. That will be the lower quartile, and 66 will be the upper quartile there. Okay. If you're not sure, you can work your way in 3, 4, 1, 2, 3, 4. Go in another one each, and they meet in the middle here. Okay. So we have some information about the ages of the two coaches. Richard says that coach A are younger. So let's have a look at each data point. We've got 59 for the median. So yep, they're younger there. The lower quartile is younger. Everything there is younger. So you would say yes to that one because all of the measures are younger. All measures, e.g. median, are younger. So I would agree with that. Coach A varies more in age than the people on Coach B. Is Richard correct? So Coach A varies more. So when we're looking at the spread of data, we're looking at the interquartile range here. So 66 minus 53, that's a range of 13. And the range of the interquartile range here is 19 there. Okay, so I would say that the spread of data for Coach B is more because the interquartile range is bigger. Let's have a look. Least age and greatest age. So that's a difference of 43, and these differ by 38. So yeah, I would say that the spread of data for B is more. Question 12, we have three spheres. Q is 50% more than the volume of P. So if we take P and then we times it by 1.5, that's the volume of Q, and then we times it by another 1.5, so that gives us 150% again of Q. Okay, so it's not 50% more than another, that's not 100% more, it's 150% more, and then you work out 150% of that. So what we have here is that the volume of R is equal to 1.5 is the same as 3 over 2, and if I square that I get 9 over 4. So R is 9 over 4 lots of the volume of P, but it asks us for P in terms of R, so we're going to times both sides by 4, that gives us 9P, and then divide by 9, so I get P equals 4R over 9, like that. We've got to prove that n squared minus n is never odd. Okay, the way to do that is to factor out the n, and then we can sort of say, well, if n is even, then n minus 1 is going to be odd. So when we multiply the even by the odd, we'll get an even number there. And then if n is odd, then we're multiplying that by n minus 1, which must be even. So we're also going to get an even there. Okay, so a little sentence for each of those will be enough to prove it once you've done the factoring out of the n's. Okay, trig ratios here. To help you out, I don't know if you've seen this before, but if we have an equilateral triangle here with a 60 and each length is 1, then we can use that to deduce the rest of these angles. Okay, so if we're looking at just this triangle down here and we've got the 60 like that, then this length here is 1, the bottom length is a half. So by Pythagoras we do 1 squared minus a half squared, and we get 1 minus a quarter is 3 quarters, and then I'm going to square root that to get root 3 over 2 for the length of this. Okay, so if we want to work out tan, sine or cos of 60, or we could have 30 here and this right side now becomes the adjacent, then we can use that to find all of these trig ratios. So we'll start with the 30, and tan is opposite, which was the half, that's opposite of the 30, and we're going to do that divided by the adjacent, which is root 3 over 2. So a half divided by a fraction is times and flip. So we get 1 over root 3 when we cross cancel these. So tan 30 is 1 over root 3. Sine 60 is going to be the opposite, which is root 3 over 2, divided by the hypotenuse, which is 1. So root 3 over 2, and then we're going to do 1 over root 3 times root 3 over 2, cross cancel these, and we get a half. Volumes of spheres and cones. The diameter, we're never interested in the diameter, we want the radius, which is 3. So we can now work out the volume of the cone. So volume of the cone is going to be 1/3 pi r squared, so 3 squared times the height. That gives us 1/3 times 9 is 3, times 10, that's 30 pi. The volume of the sphere, well, it's a hemisphere actually, is going to be half of 4/3 pi r cubed is 2/3 pi r cubed, and r is 3 cubed, like that. So we need 2/3 of 27, so 1/3 would be 9, so 2/3 is going to be 18 pi. Add those together and we get k is going to be 48, okay, because it wants it in the form of k pi. So 48 pi, so k is 48. Combination lock goes up to 5, so work out the number of different 3-digit numbers. So we can have 1, 2, 3, 4, 5, so 5 times 5 times 5, like that. So 125 different combinations there. For part B, how many of the possible 3-digit numbers have 3 different digits? So you can't have any 2 or more the same. So if we do this as a probability, the probability of picking a number is like a 1 in 5 chance, and then you multiply that by a 1 in 4, because we can't have the one that you just picked. So let's say you picked 5 first of all, then you'd have to have the 4. There's only 4 remaining possibilities, and then when you do that again, there's only 3 left. So this is kind of like a 1 in 60 chance of actually doing that. So there's 60 different ways of doing that. When we have ratios, we can actually divide them. Okay, so we can turn this into an algebraic fraction like this, and we can then solve that. So if you ever have ratios that are equal to each other, they're actually fractions. So we can cross multiply these, and we get this, and we can rearrange this into a quadratic that we can, minus 5 equals 0. So we're going to need a 2x and an x. We're going to need 5 and 1, so plus 2 and then minus 5. So 2 lots of plus 1 minus 5. So our x value is going to be 5 over 2 or negative 1 when we take those brackets and rearrange them. Okay, thirds, root 3 and root 12 is the same as 4 times 3. So we can separate that second one into root 4 times root 3, and that's going to be 2 root 3. So when we have a root 3 and we add another 2 lots of root 3, we get 3 lots of root 3, like that. Express 1 over root 3 to the power of 7. Well, we have to rationalize the denominator first, so we're going to do 1 over root 3 times root 3 over root 3, and that gives us root 3 over 3. And now we're going to raise that to the power of 7, so root 3 over 3 to the 7 is the same as root 3 times root 3 to the 6, okay? Because we've got root 3 to the 7, so I'm just taking one of those root 3's out because I know I need a root in the final answer here. And the denominator is going to be 3 to the 7 because we're raising everything to the power of 7, okay? The reason I've kept that even power there on the top is because root 3 is the 3 to the half, and I times that by 6 to get 3 to the 3 over 3 to the 7, because I can actually now cancel these. So I've got 3 to the power of 4 when I do 3 cubed divided by 3 to the 7. Okay, so we've got root 3 over 3 to the 4 is 81, like that. So B is 3 and C is 81. Question 19 is completing the square. So we're going to take the B term in front of the x and half it, and we can subtract 3 squared and plus the 1 that was originally there. So we're going to have x minus 3 all squared minus 9 plus 1 is negative 8. So there's A there, and B, because it's got a minus sign, B is going to be positive 8, like that. Okay, the turning point of this, when we plot this, is the opposite of the negative 3, so plus 3, and the minus 8 down there. So minus 8 and 3 would be the turning point of that curve. So 3, negative 8. For question 20, we have A is inversely proportional to P, so it's proportional to 1 over P, and P is directly proportional to the square root of T. Alright, so we're going to change this into H equals K over P, because we always change it to equals K, but in this case, we've got a different proportionality, so I'm going to use a different letter here. Let's just use, I don't know, F over, sorry, not over, P is equal to F root T. Alright, it's directly proportional to. So we can substitute in some of these values. When H equals 10, then P is equal to 6, so K is equal to 60, and then we can rewrite this as H equals 60 over P. And in this case, when P is 6, then T is going to be 144, so root 144, which is 12. So I'm going to divide both sides by 12, and I get 6 over 12, which is a half. So a half equals F, so this one is P is equal to a half root T. And then we need to link these two together to eliminate the P, because this is wanting H in terms of T. So I'm going to rearrange this to get P is equal to 60 over H, and then I can substitute that into this other one, and I get 60 over H is equal to a half root T. Times both sides by 2 to clear this denominator, and I get 120 over H is equal to root T, and I want H, so I'm going to cross this, so I get H is equal to 120 over root T. Question 21 is a functions question. We want the inverse, so we're going to replace the f of x with a y, switch the x's and y's around, and then make y the subject. So x plus 1 equals 3y, so y is x plus 1 over 3. That's our inverse function, x plus 1 over 3. For part B, we have fg of x is equal to 2gf of x, so we have to actually work these out. So g of x is x squared plus 4, and I'm going to replace that into f of x. And on this side, we're going to have 2g, and we want f of x to go into that, so 3x minus 1 there. So x squared plus 4, when we put it into f of x, is going to be 3 lots of x squared plus 4, because I've replaced the x from up there and then subtracted 1, and then 2 lots of g of 3x minus 1, so we're going to do 3x minus 1 squared plus 4, like that. Okay, so I've replaced the x with the 3x minus 1, and it's all squared. So we clean this up a bit. 3x squared plus 12 minus 1 is plus 11, is equal to 2 lots of, let's double bracket this thing, 3x minus 1 squared, and we get 9x squared minus 3x plus 1 plus the 4 that was already there, and we get 18x squared minus 12x plus 10. When we subtract 3x squared from both sides, so let's just do that from here, we're going to subtract 3x squared like that, and we're going to subtract 11 from both sides. So that gives us 0 equals 15x squared minus 12x plus 10 minus 11 is minus 1. Question 22, there are only red and green counters in a bag. The probability that the counter is green is 3/7. So the probability that we're going to get green over the total, which is red plus green, is equal to 3/7. So we can cross multiply, and we get 7g is equal to 3 lots of r plus g. And then we get 7g is equal to 3r plus 3g, so 4g is equal to 3r when we rearrange that. 2 more red counters and 3 more green counters put in, then we get the probability that the counter is green again, so we've got the probability of getting a green this time is going to be green plus 3, because the green is the original number that we had, so we have to add 3 to that. And that's divided by the new total, which is the red plus the green plus the 2 more red plus the 3 more green. So that's another 5, like that. So this time we've got this equation that we're going to rearrange. So 13 lots of g plus 3 is equal to 6 lots of r plus g plus 5. And we can expand this out to get this 6r plus 6g plus 30. And I got a combination here of r's and g's, but 2 simultaneous equations, so I'm going to substitute for one of these. Which one shall I do? Let's just double that to get 6r equals 8g. That will help us out. So 13g plus 39, 6r was 8g, and we can now start collecting these together. So we've got 14g there and 13 on the right, so we're going to subtract 13g from both sides to give us g, and take the 30 over and make it a minus, and we get 39 minus 30, which is 9. So g is equal to 9, and so r is equal to 4g over 3 when I rearrange that. So r is equal to 4 lots of 9, which is 36 over 3, r is equal to 12. Okay? So to find the number of red counters, so yeah, green is 9 and red is 12. So that's the end of the paper. I hope that was useful to you and you can follow that through. I went through it a little bit quickly, as I was told by one of my students that I talk a little bit slowly on the videos. So hopefully the pace was okay for you. Let me know in the comments below if it's too quick or too slow, and I'll try and change that for you for next time. But I hope that was useful. Find the grade boundaries on the Edexcel website and give yourself a grade for this out of 9.